Yeah, so I'm Rajat here. Uh, so going with the theme of today's presentation, I'll be talking about DevOps and how we use DevOps in Soda Foundation to solve day-to-day orchestration and integration challenges that we face with microservices. Yeah, so I'll be taking you over a journey of how the tools and technologies involved uh, in using DevOps in my Soda Foundation. I'm starting with the first slide. Soda DevOps. Yeah. So the agenda for today is basically I'll be taking you over high-level overview of the Soda architecture. Uh, then we'll go briefly over the microservices overview. Since we are talking about microservices, DevOps comes by default. So we'll have a look at what is DevOps, how it plays a role in simplifying the microservices deployment and orchestration. Then I'll talk about the various tools and technologies that we use uh, in Soda to solve the Soda is a microservices based project. So it involves various challenges of orchestration and integration. Uh, so we use DevOps to solve the challenges. So let's see how. Uh, so I'll be talking about uh, the Soda architecture just to give a perspective of what are the challenges that we face and how we solve them using DevOps. So since Soda is built of various microservices, we'll see what microservices are and how they can help us to solve um, uh, issues faced by monolithic architecture. Since we are talking about microservices, we also need to know about the DevOps, so which is basically development and operations combined, which helps us to solve the various challenges that we face in microservices. Thereafter, I'll be taking you through the various tools and technologies we use in Soda Foundation to solve these orchestration and integration challenges. So some of the tools which we use are Ansible, Travis, SonarQube, Jenkins, Angular, and Swagger. So without much ado, let me introduce the architecture to you. So as you can see, the architecture is a pretty vast one and it has a lot of moving pieces. So this is not going to be a deep dive into the architecture. For that, we have a much more deep dive session tomorrow from morning to 10 to around 2. So you'll get a good perspective of each of these services in tomorrow's session. However, this is a trailer to somewhat like a trailer to that session. So I'll just introduce the various core pieces of Soda project. So to begin with, we have the Soda backends, which is basically your storage arrays, storage infrastructure, which we plan to manage, monitor and manage via the Soda project. So each of these storage backends, they talk to the Soda framework via uh, the southbound interfaces, which helps us to bring in all the data from the storage infrastructure into the purview of Soda. And once the data is within the Soda subsystem, we have the Soda infrastructure manager, which is basically called the Delphin, which helps us to do collection management, resource management, alert management. The Delphin talks to the controller, which basically controller provides the metadata management and also provides the flow of the API flow from all the way from API to the storage backends. Um, so the controller is kind of the glue between the southbound interfaces and the northbound interfaces. So the controller directly interfaces with the API, which is basically kind of a standardization of various APIs that talk to the northbound plugins. So using these APIs, any of the applications, third-party applications or the dashboard can integrate with the SOTA framework and get all the data to manage the various storage infrastructure that we are planning to manage. So alongside these core pieces, we also have the multi-cloud, which is basically uh, a system to manage the vendor agnostic way of managing and monitoring the cloud resources that we have on the clouds that are supported by SODA. So right now we are monitoring and managing resources on AWS, Azure, GCP, uh, Huawei Cloud, and so on. So along these, other than these pieces, we also have the sidekicks, which is the installer, the orchestration piece, anomaly detection, and documentation, and so on. So as you can see, it's quite a busy slide, and we have quite a few moving pieces uh, going with the along. We have quite a few moving pieces due to the microservices architecture that we have followed. So with microservices, we get its own challenges and which need to be solved using tools from DevOps. So since we are talking about microservices, so let's just go over what microservices are and how they help us solve the challenges which monolithic brought about in the previous few years. So earlier, monolithic was the only way of building products, but it has its own set of challenges. Um, so it was simple and easy to start with, but as the services grew and as the product became larger and larger, it brought about its own challenges, which were difficult to solve by just the monolithic architecture. So uh, various research and various thoughts went into how to solve these challenges, and then we came about with microservices. So let's see what are the even though monolithic and microservices have their own pros and cons. Since we have moved on to the microservices, let's see what the cons of monolithic are and what the pros of microservices are. So when we talk about monolithic, it's to begin with, it's a monolithic. That is, it's a one piece that is developed and delivered at the end of the release cycle. So since all the features of the product go into a single piece, it takes a long time to build, test, and has longer release cycles. Some so ranging from anywhere from 3 months to a year. Then it becomes difficult to scale the product or the teams after a certain point in time when the product has become feature rich. Operations for monolithic services is a nightmare. So since it has a single point of failure, deploying and testing and releasing monolithic products becomes really a nightmare. Then the architecture, as it evolves over a period of time, becomes harder to maintain. So it takes a longer time for new folks to come into the monolithic architecture and start contributing. Uh, so also, the features of monolithic products are quite tightly coupled, and that gives us a very no room uh, for improving on the technology set or trying out new technologies for various different services. So upgrading the technology becomes really difficult in that case. So which brings us to the lack of agility. We are not quite agile, and the delivery of the product is slow in that way, and due to which the releases takes months, if not years. So all of this leads to a delay in product delivery, and the customers are kept waiting for quite some time. So which is not really a good space. So to solve these challenges, folks from the industry, they put their brain together and came up with something called microservices. So microservices, as per Adrian from Netflix, he says that it's a loosely coupled service-oriented architecture within bounded contexts. So, which means that instead of just delivering one service, we deliver multiple services which are loosely coupled the service-oriented architecture and which solve a particular business problem. Then we have from Martin Fowler, what he says that the microservices is a architectural style, is an approach to developing single application as a suite of small services, each running in its own process and communicating with lightweight mechanisms, often an HTTP resource API. So the focus is on architectural style, and it's a small suite of it's a single application built up of smaller pieces, each running in their own process and solving the bigger business problem at hand. So with that, let's look at what the benefits or the pros of microservices are. So since we are dealing in microservices, which is a smaller piece of the service, and each piece of the service is focused on doing just solving one problem and solving it really well. So that the concern is just solving one problem for one service, and each of these services again interact with each other to solve the larger business problem. So let's look at what are the various characteristics of microservices are. So each of these services are componentized via services. So these all the intelligent pieces are within the services, and the connection, that is the connection between two services, is via dumb pipelines. So each of these services are loosely coupled, which makes it easier for us to start, stop, or replace any service, failing service. So that way, it's pretty agile that way. So we again in microservices, the data management is not like a monolithic; it's a decentralized. So that means each service can have its own database or own data set to operate upon, and just communicate the result of that operation to the other services. Then thereafter we have since we are dealing with multiple microservices, so we need to have an infrastructure automation. So we to test and to deploy the services, automation plays a very important role here, because we are not just building one monolithic, we are building multiple smaller services. So to test all of these in a whole, infrastructure automation is paramount. So since we have multiple moving pieces in microservices, which with any of these services liable to failing anytime, so we design for failure. So we know that, okay, some service is going to go down at certain point in time. So we design for that, and we always have a backup or highly scalable services, so that any downtime time can be factored into the design and taken care of. So also the benefit of microservices is that we have a evolutionary design. So that means if a new technology is coming along and which solves a current business problem really well, and we want to adopt that, that can be easily done in microservices as compared to the monolithic. So since the microservices are small, we can get rid of the existing microservice and bring in the new technology to solve the business problem. So since microservices are small, it's easy to maintain them and easy to test at a smaller level. And it's easy to deploy these microservices on any given infrastructure, and to, we can test the deployability that way. Okay, so all since the microservices are smaller in size, they can be owned by small teams who will be responsible for end to end. Okay, so that gives the perspective of what the microservices is. And now to solve the DevOps part of the puzzle. So let's see what DevOps exactly is and how we can use DevOps to solve the challenges thrown upon by microservices. So DevOps is essentially an infinite loop of uh, build, plan, then deploy, operate, and then get continuous feedback and continuously integrate. All of this is encapsulated into real-time communication. So communication is a very vital factor of DevOps. So as you can see, it's quite a busy slide here, which shows that there are whole gamut of tools and technologies available for supporting the microservices through DevOps pipeline. So, but this is not really to scare you. This is just to show that there are so many options of tools and technologies to use to pick up from and use as per your uh, as per the challenge that you're facing. So, and not everyone uses all of these tools. So we pick and choose what fits our business need. So let's see what we use so far in Soda. So as you can see, this is a small subset of the tool chain that we use in Soda. And so we use tools all the way from documentation and uh, developing architecture slides and charts using draw.io and Google Drive to store them. Um, then Lucid charts to make charts, Git for for the source repository, Kubernetes for deployment, and so on. And here we have the cloud services, which are used in the microservice and the multi-cloud services. We have GCP, Azure, AWS. Uh, then we have the CI and CD tools, which is used for CI, Travis and Circle CI, Jenkins. Ansible is used for installation. Slack is used for day-to-day communication and so on. So these tools help us solve the various challenges which we face in uh, deploying and integrating these microservices together to solve the business problem. Okay, moving on. So I'll be talking through the various tools and technologies we use in Soda to solve these business problems which we face. So installation is done through Ansible. Ansible was the tool of choice for installation because of its simplicity. To begin with, it is a agentless automation tool. So that reduces the maintainability from our side. So we don't have to maintain any particular agent to deploy on all the clients. Since it is agentless, it is that much more simpler. So it is used for configuring systems, deploying software, and orchestrating IT tasks. Um, it's easy to get started for any new beginner with Ansible because its syntax is pretty much like JSON. It's easy to learn and get started, and it is properly organized and modularized into modules, playbooks, and roles which are reusable. Uh, then the Ansible by itself is loosely coupled and helps us in easy maintenance of the code bases. Some of the other tools which are similar like Ansible, which solve the same problems are Chef, Puppet, Salt, Terraform, and Kubernetes. Now coming to Soda installation part, we also have installation through various other mechanisms. Like the installation can be done through Salt. We can use Kubernetes Helm charts for deploying Soda. And we also have shell script for local installation. So we have quite a few options of for installing Soda and trying out Soda. Uh, so one of the key things that we have done in Soda is that each of the Soda services is independently installable, which goes along with the microservices architecture theme. Um, so each of these services can be easily independently installed, which is required for automation, for testing each of the services independently. And also one care that we have taken in for CI for the installer is cumulative, which means that the CI for the installer only passes when all of the CI for the other services also pass. So that way, the sanity is done for the installer during the CI phase itself. So which keeps the installer healthy and uh, avoids any breakages if at all. Then thereafter we have the orchestration. So to orchestrate, that is to deploy various services for the Soda Foundation, we use Docker Compose. Uh, so Docker Compose fits really well with Docker since they are from the same stable. And mm, so Docker Compose basically takes up the containers which are built using the Docker files, and then deploys them together so that they form a service, and they solve the business problem that way. It's a easy tool to get started with. Similar like Ansible, it has a syntax in YAML, which is easy to read and understand, and easy to learn as well. Also, it provides a single command to create, start, and stop all the services from the configuration. Uh, Commands for managing the whole life cycle of the applications are provided, which include start, stop, rebuild services, view the status of any service. We can also stream the logs of the running services to a centralized location. Um, we can also do patching of the services with a one-off command. So all in all, Docker Compose is the heart of orchestration for any of the microservices. So similar such tools are available, which can be tried out. So they are Kubernetes, Docker Swarm, Helm, and Terraform. So out of all these, Docker Compose was the tool of choice because the containers we built using Docker. So it goes by default. The Docker Compose is kind of an extension of Docker. So that's the reason for choosing Docker. All right. So the next important part for maintaining the health of the various services in the Soda Foundation is CI. So CI basically is your continuous integration. So we need CI for continuously integrate the services which we build, and continuously test it before that goes into the merged into the master. For that we use CI. For that, the tool of choice for CI was Travis. Firstly, because it has good support for open source projects, and it's quick to set up and integrate with GitHub, where we store all our code artifacts. And then we get a view of the live builds as and when the CI is happening on Travis. Um, Also it gives a good pull request support. That means whenever a new pull request is submitted, the CI builds are run, sanity is done, and then once it passes, only then can it be merged. So it acts like a good gateway for filtering out failing builds and so on. Also, one good feature of CI is it provides auto deployment of the passing builds. That means once the build is passing, the build can be deployed and tested. And it provides a clean VM for every build. So other tools which can be alternatives of Travis are Circle CI, Jenkins, Bamboo, and GoCD. Okay, static code checks is another way of maintaining the sanity of the code base and unearthing defects and bugs early. Uh, so, so these are based on configurable. These are based on configurable rules, uh, uh, which we can configure as and when we integrate new languages into the pipeline. So SonarQube supports quite a vast range of languages. It goes with the polyglot mechanisms of microservices. It supports a large number of languages. So that way, it can be used across multiple services which are in from different languages. Uh, Also, SonarCube is hosted on cloud as Sonar Cloud, so which can be integrated easily with any of the projects. So after all this, we have the deployment. Once we have built the services, we would like to deploy it. So Jenkins offers a good deployment service, which can be used to deploy the services to pre-configured infrastructure and do smoke tests before smoke tests and various other tests post the development cycle. Uh, all right, and the last piece is the Angular, which is used for UI. So Angular gives a good way of deploying, so using UI for each of the backends. So right now we are using the monolithic UI way of user interface, which basically each of the microservices connect to the single UI service, and they can be all the services can be accessed through a single UI. However, as and when we add more services and features to the Soda, we'll be migrating to a composite UI, wherein each front end there is a dedicated front end for the dedicated backend, so that any failures or any upgrades or issues can be localized to that particular front end piece and can be solved easily.